On Monday, we looked at inequalities with one inequality sign, and a compound one usually has two. And there's basically two types. There's basically and there's ors. So those are the two types, which we call an and an or. All right. And the concept kind of behind and is x is between, say, 3 and 7. So if we had, say we wanted to pick a number between 3 and 7, then that would be an and problem, because I'm saying I want a number between 3 and 7. So the and automatically comes out. So this would be like an and problem. Graphically, on a number line, so we're talking about all the numbers in between there, because you could pick a decimal. I guess nobody would. Maybe it would. But you could pick any kind of number in there. All right, so that's called an and sort of a problem. And what we're looking for is if we divide this into two parts. So the first part would be x is greater than 3 or equal to it. So that would be 3 going this way. This one would be x is less than or equal to 7. So x is going this way. So the overlap is the answer. So to kind of illustrate that maybe with some colors, so that would be this way, and this one would be this way. So the overlap would be what's in between there. All right, so that would be kind of this stuff. All right, so when you're doing an and problem, it has to meet both conditions. You're looking for the overlap, which is usually going to be between there. All right, that's an and problem. Ors would be something like, I want a number that, say, is less than or equal to 3, or I want a number that's greater than or equal to 7. So in this case, it's different. So here's 3, and here's 7, and this time we're going to go this way, and we're going to go this way. All right. And there's no overlap, because there shouldn't be in an or. Because you're saying I want one or the other. So you can't meet both cases, where in the and you're saying I want it to be both greater than 3 and less than 7. But here is I just want it to be one or the other. All right? So those are the two situations you're going to get on compound inequalities. All right, so kind of hopefully you kind of see that. That's the real concept behind it. All right? If you understand that, you're in really good shape. So basically, I'm just going to go through and solve some of these. I'm looking at them. Most of them they want you to write using interval notation. There's a couple of them they want you to graph on a number line, but I really don't know how much graphing on a number line you really need to do. So I'm assuming that you pretty much know how to do that. So if you want to just continue to write them using interval notation, maybe do like 2 or 3 of them graphically. That would probably work out. I'm not going to get too excited if you don't. I just want to. Graphing's kind of a, I don't know, it's kind of tedious, I guess, way of doing it. But all right, so let's go ahead and let's see. We'll do some of these. Those ones are pretty straightforward. Okay. I'm assuming that some of you are pretty familiar with interval notation because you already do it. But that's where they start out at. So they go on 3. Well, here, I'll pick a different number. 2 is less than x, less than 5. So that's an and problem. All right. And they want us to write the solution to that using interval notation. So a bracket means that it's going to contain that number. So in this case, we'd have 2 here. And a parenthesis means it's not going to contain that number. So we would write it like that. But a lot of you are already doing some of that stuff. So whenever you picked it up, you got it figured out. So, but that's what they're going to have you do.
No comma in between?
You know, I've seen it kind of both ways. See, when I think of it, the problem is and this was just with parentheses. I don't know if that's a point or if they're talking about an interval thing, you know. So I think it's kind of a, I don't know if there really is a proper way to doing it. It's probably just a teacher preference thing. If you put a comma there, I'm not going to mark it wrong. All right.
Okay.
I guess it's just a me thing. Let's see. What about what about something like this? X is less than or equal to 1. So now we're talking about just a single thing here. So less than or equal to 1 means it's going to go that way. So we'd go negative infinity with a parentheses to 1 with a bracket. All right, because it's going small, it's going less. All right, so then we go all the way to negative infinity. So you write it like that. On the flip side, if you had x is greater than 2, then you're going in a positive direction. So it would be parentheses 2, because it's not equal to positive infinity with a parenthesis. All right. And you don't have to put a plus sign on the positive infinity because it's already, just like a number, it's said to be positive. All right. Any questions on that right there? I think most of you are pretty good with that.
That's not a bracket at the end of the parentheses?
Because it's not
Right here?
Yeah.
Because it's not equal to it.
Oh, okay. So only when it's equal.
When it's equal, you have a bracket. When it's not, you go with a parenthesis because it doesn't contain the 2.
Do you want us to use the notation for the and or? Like
The U and the N? You can do that if you want to. Or you can just put and or. Did somebody have you do that?
Yeah, in math 70.
Oh yeah, they had to use the U and the N.
Mm-hmm.
Can I ask if they were an old person?
She wasn't that old.
Okay. That's like 1960s mathematics. I remember learning that. I was just wondering. Okay. It doesn't matter if you do it that way. It's just kind of fun. I was just kind of curious. All right. So that's going to be like the first some of them you just do. You just put them in an interval notation using the parentheses and so forth. All right. Let's see. Let's do. I really think we should just kind of get into some of these. So let's go -3 less than or equal to x minus 5 less than or equal to 8, like that. Now this one is an and because x minus 5 has to be greater than or equal to -3 and less than or equal to 8. So see the and kind of comes out on that. And all we have to do here is just add 5 to the whole thing, just like this. So 2x 13. And it says write an interval notation. They like interval notation here. 2, 13, bracket, bracket, because again we have equal to there. All right. Let's see. Oops. I really want to do one like this. There. Let's try one like this. What's this one, an and or an or? And, yeah. Okay. What do you think we should do first? Yep. So I'm just going to -3. So the whole thing like that. This is an 11. Kind of messy, kind of messed up on me there. The pen did. Okay, then what? Yeah, so now I'm going to divide by -2. Okay, so we'll divide this. So the 11 divided by -2, so that's going to be 5.5, correct? X. 7 divided by -2, -3.5. Now, we divided by a negative, so what's going to happen? Yeah, so these signs will flip like that. Okay? Now, I will say this, though. It is better if you write so that the negative number or the smallest number is first. Okay? Again, it wouldn't be something that I would say, oh, that's wrong, but it's more proper to do it that way. Does anybody have their syllabus out to tell me what problems we're doing in this section? Are we doing any in this, like, in the 77, 78, 79, 80s? I don't have mine out, so. Oh, you can just tell me if it. What's our assignment on this?
77, 78, 81,
Okay.
85.
Good enough. All right, so let's do one like that then. So let's see. -2 less than or equal to 2x plus 1 over 3 less than or equal to 4. So we'll do one like this then, because there's one like this on the assignment. All right. Again, this is just another and. I should do an or sometime. Let's see. What are we going? How would we attack this one? What are we going to do here? Multiply by what?
3.
3. What a great idea. Clear that bottom. What are we going to get? Yep, make sure you go all the way through, correct? All right, so we want to make sure that we're hitting both the -2 and the 4. And now we just work it out. So what are we going to do next?
Subtract 1.
Yep, we just subtract 1 all the way through. -7 here, 2x and 11. Again, I made these up so you can tell they never come out to be nice. Here's that. Here's that. Okay. Oh, I guess I'm supposed to be putting all these in interval notation. Oh my goodness. There we go. Okay, are we good with that one? Okay, let's do an OR problem here so we can get one in. Let's see. 3 plus x is greater than 2, or 3 plus x is less than -4. Hey, bet you can't guess what kind of problem this one is.
I have a question real quick.
Yeah.
So on the question before, the -3.5, do we not flip it? The one we just did with
The 2x plus 1.
No, because it wasn't divided by a -2.
Oh.
If it was a negative number,
Oh,
then you
okay.
divide by it.
All right.
Yeah, you want, yeah.
I wrote that down for myself. So.
Okay.
Great. Good, yeah, good thinking. All right, so here's our OR problem. So what should we do here? Yeah, subtract subtract 3. And we can do that all the way. See? It really doesn't change anything. Okay. So that's where you would use that u if you wanted to, right? Okay. Let's see. Right. Solve the compounding, graph the solution. I wouldn't graph these, but I'd probably either leave it like that, or if you wanted to, x has got to be greater than -1, so that'd be -1 bracket or parenthesis. Yeah. So we're going greater, so that's going to be positive infinity. Okay. Or, oops, less than -7, so it's negative infinity, -7 parentheses. Okay. Union means or, and this means intersection, which is an and, just in case you see that somewhere. All right. Did we do any, are there any assigned in the 81, 82, 83, 84 ones? Or 85, 86, 87, 88s?
85, 81 through 85.
Okay. All right, so 80, you know what, actually let's take a look at 81. Why don't we just do that? So on 129, let's just do one, we'll just do 81. What the heck? We'll just do it. So this is number 81 on page 129. Okay? So it says, are we there? Yeah? Okay. Use the table to solve the three-part inequality. Write your answer in interval notation. So here's the little inequality that I'm doing. Okay, and then it gives me a table. X, Y, and let's see, we have -2, -1, 0. You don't, I mean, copy the table if you want to, but it's all right there. 2, 3, 4, -4. No, it can't be. It's got to be -6. -3, 0, 3, 6, 9, and 12. So it should be something like that. All right, so now we want to solve this. So we basically want to know when y is between -3 and 6, because it's an and problem. So we want to know, okay, when is it between these two numbers? Well, here's -3 and here's 6. So what x numbers correspond with those? -1 and 2. Yeah, my table's not very good. Okay. All right. So then my answer would just be interval notation, I think they wanted. So I got parentheses, -1, parentheses, or 2, and then parentheses, because yeah, those are the x's that correspond with these, and everything else is good. All right. Okay. Do you see kind of how they want you to do that? Okay. All right. Let's take a look at 85. It says use the graph to solve the compound inequality. Write your answer in interval notation. So here's what they want. Like this, and like this, y1, and like that. Oh. And they have this kind of deal here. And my bet is this is a 2 and this is at -2. Okay, let me change the color a little bit here so we'll get a mixture. There we go. All right? So, in this case, again, we want to estimate these x's. So we would come down to here, figure out, well, when is this graph here equal to 2? I don't know what x that is because I just sketched it. Anyway, is it 1?
Yeah.
Okay, and then we're going to do the same thing here. All right. Oh, here, sorry. So what does this one lead us to? Negative 3. Okay, so this is an and problem. So we're going to say, all right, we're going to go negative 3 to 1. It's equal to, so bracket, bracket. So we're talking about the numbers between here and here. Now the graph one kind of tossed us a little bit last time. How'd this one any? You see kind of what we're doing here on this one? That's the end of that. There's nothing much else on there. Okay. So no questions on 2, 4. We're good. Yeah, that's it. Yeah. Not too bad. Okay. Let's get into a little bit of 2-5, and then we'll take a little break here. Okay. Let's do this to start us off with. Wow, there's a Desmos graphing on this thing. Okay. All right. So I'm going to graph an absolute value here, and I should also do it on the A9, so you know how to do it on that. Desmos has a number of different functions. You can click on them over here. A whole bunch of trig functions that we'll never don't think we're going to get into. Stats, for those of you who will get into that someday maybe. Miscellaneous has some miscellaneous stuff on here, and one of them is called absolute value, which is ABS. So you can simply just type ABS. You don't even really need to worry about the function thing. Okay, so if you hit ABS using the ABC, that'll work just fine. All right, that's usually what I do. Absolute value of x looks like that. Okay, so there's an absolute value function. It's shaped in the term of a v, and that is because, what do we know about absolute values?
No sign associated with it.
There's no sign that stays with them? Okay, so what does that mean? Can you elaborate a little bit more on that? You're right, but
Just a distance on a number line.
it's a distance. Actually, you're absolutely right. Okay, it's associated with distance. Good for you. Yep. So if we're going to go from, you know, here, point H, over to poop. There we go. We're going to go from H to, say, I don't know, here to Forest Grove or whatever you want to think of it, North Plains. Okay. There's a certain distance involved in that, and if you reverse that distance, the distance is the same. It's just a reverse direction, right? But it's still however many handful of miles that it is. So you're right. Absolute value is distance. It's not positive. It's always positive. Okay. So the absolute value of a negative 10 is 10. And the absolute value of a positive 10 is 10. And that is why you get a V. Okay. Absolute value is going to be a positive, is associated with a positive value. All right. So when we graph absolute value, we get a V. All right. With that being said, I'm going to leave this. Is that okay? All right. I'm going to go back to this. if I want to solve an absolute value equation, there's my v. Let's say I want to figure out what the absolute value of is equal to 5. Now that's pretty simple because I know what that is, but let me show you. So I'm going to put y equals 5 in here. Okay, so this time we're going to get two answers because this line crosses the absolute value in two spots. Why is it crossing in two spots? What's the absolute value of negative 5? And the absolute value of 5? There you go. Okay. So when we're solving absolute value equations, something like that could occur. All right, where we get that. That's how you, graphically, it's pretty easy to solve that, really. So let's go back to, I'm flopping back and forth here. Let's say we're going to solve the absolute value of x minus, x minus 3, okay, is equal to 7. All right. So then what I'm going to do is I would graph the x minus 3 part, and I would graph the 7 part, and then we're going to find out where those cross, just like we were doing before. It's no different. All right, so here we go. I'm going to get rid of this guy. Well, I'll just put minus 3 in here. Okay, put 7 down here. All right, and there's my answers. Let's see, it says negative 4 and 10. Okay. Let's see here. I'll pull up the 89 thing so we can get that. Okay, so, oops, it went away. So the answer was negative 4 and 10. All right, graphically, right? That's how we solved it graphically. But remember, there's always some people who just got to do it symbolically. All right, how do I? This is not a 5. That's an S. Symbolically, okay, because they gravitate towards that. So you can say, well, really, how do I do it? Here's how you do it. We're going to go x minus 3 is equal to 7. That's the obvious answer. But we just talked about that since it's absolute value, x minus 3 could also be equal to what other number?
Negative number.
Negative what?
7.
Yeah, right. Because it's going to be positive, correct? So when we do this symbolically, then we're going to split this up into two situations where we have x minus 3 is equal to the obvious case, but also we're going to say x minus 3 is equal to the negative part. And then you just do it. Okay? And you can see, oh, hey, there's where the 10 and the negative 4 come in. Okay?
So like on tests, do you prefer one? Do you prefer us to like show it for graphing, or is it like a choice we could do between the two?
I don't, you know, I'd probably say something like this. I might just have you just solve it any way you want. Probably most people are going to gravitate symbolically. But then I might have it where you would solve it symbolically and verify your answer graphically.
Okay.
Okay. On the 89 or 83 that you have, clear. Let's see. For the 89, you can just type ABS again. That's going to work. So you got to hit the alpha key. And if you hit the alpha key twice, it will continue to, you don't have to keep hitting the alpha key. It will just keep looking for letters. And that's okay. That's kind of a nice feature. At least you think it is. And then now if you hit anything else, it's just going to go purple. So like I want the parenthesis now. So I'd have to take the alpha key and turn it off by hitting it again. And then I could put that in there. What was it? X minus 3. And close it with a parenthesis, press enter, and then graph it. And there it is. Okay. 83, 84, folks. There's a math key on there, right? So if you go, I gotta look at an 83. Let's see. Y equals, right? No, that's okay. I got it. Y equals. Okay. And then there's a math button on there, right? Okay. And is ABS in the math button?
It's math, and then you move over to the right to go to numbers.
To num?
And it's number 1.
Okay. I knew it was in there someplace. Okay. So if you're using that calculator, so it would be math, num, ABS is right there. Okay. That's how you do that.
You just show us that. So ABS
Let's try a couple more before we do a break here. So let's go absolute value 2x minus 3 equal to, if I choose 10, it's not going to be very nice, 11. All right? Okay, so symbolically, what's this going to look like?
2x minus 3 would be 11. Oh, actually, minus 3 equals -11.
Mm-hmm. So then we just solve it, right? And if you graphed it, it would verify those. Okay. So, yeah, we're just breaking it up into two cases, the positive part and the negative part, and working it out from there. What if it was like this? What would we do first? Yep, move that 3 over there. Okay, and work it out from there. But you want to do that before you break it into cases. Okay. So get that absolute value by itself before you break it into cases. All right, this is a good. Any questions on any of that then when we're doing there? Okay, everybody's going. No, we got it. All right, good. Okay, take a little. Let's go about 10 minutes, and then we'll come back and we'll look at the other things. We'll probably will be done a little early today, so if that makes a difference. Yep.
What's the quiz on?
Stuff from Monday.
The homework from Monday?
Mm-hmm. You did it though, so you'll be fine.
That's my
It's trouble you didn't.
I have yet to successfully figure out how to use that damn
Which one is it? Go get it.
T89.
Yeah, go get it.
A couple more questions about the homework. I just felt like I was asking a billion questions.
It's okay. We want you to ask a billion questions. Okay. What do you want to know out here? I'll give it to you. You tell me what you want to do.
Well, okay, the equation we just did,
Mhm.
I followed all your steps. Do you see a line there?
No. So go diamond y equals.
That's the last one because I cleared it out.
Okay.
Okay, so
Let's
you're
go up
saying
there.
soft button?
Let's just go up to get rid of that one. Okay, so we're all up. There we go. We're all up to it. clear. All right, now you can type whatever you want. ABS, right?
Yeah, you'll probably catch it.
Right, yep. Just here, we'll just do x plus 2.
Clicking with the S to
Parentheses.
the other part.
Okay, now enter it.
Usually for
And then the equals part you put down here. So that would be 12.
That's my issue.
That was your
Okay.
issue. Yep, I
Yep.
saw that already.
And then just hit
Time to
diamond
graph.
graph,
Did you test
right?
right in
Yep.
pre-co?
Now, the B's going to show up. The 12's probably not going to show up because it's out of your window.
Right, and then you zoom to
Zoom
get
out.
that part. The part that I wasn't getting was that the equals had to be at a separate line. All right, thank you. I still haven't figured out the decimals and stuff, but I'm getting a book before the next class.
Yeah.
Thank you.
You're welcome. You mean how to get it from a fraction to a decimal?
Yeah, it won't do
Yeah.
Control enter.
it. Yeah.
You're welcome.
That makes me happy. I was about ready to drop this.
Okay, so my other question
Yeah.
was, I don't remember what number it was,
Are you
but
green?
yes.
Okay.
But basically, like,
I
what
got this
do you
looks
want
like-
as an
yeah.
answer for inequality? Why can't I find it right now? Oh, maybe it was the other.
Cool.
I think it was 117.
Yeah.
Use
The
on the
answer guide. I don't know if you can get them separately.
He's doing a good job.
Takes a
I
while.
was gonna say I actually have an extra book.
Okay, so like, in
Yeah, I wanted the
these,
answer
like,
guide too.
what are we looking for?
Sure. Yeah. But
For an
and now I have
answer
two
of the
actual math
inequality.
guides.
Oh, okay.
So you can just switch to symbol when it changes, I think. Yeah. Yeah.
So this is from the other day. So graphically, so what they want is they would, okay, so they want you to use your calculator to graph, or what are you using? You're using a calculator, right? Okay, so the one you're looking at is it greater than 0 or less?
Less.
No, only
Like that, right?
Yeah, that makes sense.
Okay, so this gonna look like that,
Traffic's getting really bad for me. I'm gonna have to start leaving at
okay?
like 7 or
Alright.
7:15.
Less than 0, so this would be 0, this is a 0 line. Alright. Is a less gonna be above or below?
Yeah.
Hello.
Yeah,
So it's
that's
all these, correct?
Okay.
Which means it's all these. So we want all numbers that are less than equal to 1. Because that would be all
I've been
these.
trying to be.
Okay, so it's along the X.
I think I've done it.
Because you're solving for X.
Right, okay. Okay, and then, do you have a question?
Oh, you're fine.
Okay.
I don't think it. People kind of assume that was a salary.
And then when you do it symbolically, you just cover that, so
So
never
it doesn't really
mind.
matter what time we get there.
Yeah, it's like the normal equation. The only thing that changes is the
Oh.
divide by the
So long, like,
It was-
or greater to or less than, like, I just-
solve each
That's what everybody
equation
said.
for equality.
Yeah, so the B and the C are what I couldn't,
I think what they want you to do is, so the first, you got 3 answers. They want you to know when it's equal to 0, so that would be, so you set this equal to 0, and you get 2. Then when it's less than, or greater than 0, or no, less than 0, sorry, less than. So when
Oh,
this is
okay,
less than
so-
0, so x minus 2, so you just put a 0 here, make this a less than,
okay.
and then flip it into a y.
Okay, cool.
So basically, yeah, 2 is, it's gonna be 2 and then 1 less than 2 and then greater than 2. Yeah.
Okay, thank you.
Yeah.
Right, here's
Oh,
the, what I have to turn in is the one, and then the supplement, and
So it's anything
a little bit
that's-
of 2.1.
It's anything on the left side.
Okay.
You know,
Okay.
But what do you want to talk about?
depending on the perspective,
I've got
it's
an
greater than
84
either way,
plus,
right? This is
and I'm having a little bit of difficulties with the
This is
graphing
less
on
than
it.
Okay.
I just do y equals,
Right.
and then I just,
So like
I'm
the
having a little
absolute.
issues with like the absolute value.
And that's always,
Okay.
sure.
On the absolute value, so if you push the math button right there, and your arrow will put it down here, it's right there. Just press enter. Alright, and then you want to put in x, you have x plus 2. Press x right next.
Oh, see,
So x is going to be here, right there, yeah, that's right. And then we'll come down here. And let's Now, it's kind of got a funky window going here.
Yeah, what's
Okay.
going on with that?
So I'll push zoom and hit 6 for standard. And what that does is it sets you, kind of resets it, takes it
There we
back
go.
to, I don't know, 10 by 10 by 10.
Now I can see it. It makes sense now.
Okay. You know how to find that intersection point?
Yeah.
Okay, sure.
What do you mean? You mean with the arrows?
No, it's better to actually know, because it kind of, but sometimes it
They
doesn't
don't give
work.
you decimals.
So here's what we're going to do. We're going to go second rate. And this will calculate these, so we want the intersection. Now, all you really have to do is press enter. In most cases, 3 times and it's done. But the first curve, you're just going to press enter, because you only have 2 curves on the screen. Okay? Yep, again, another enter. Yes, so move this, using these arrows, move it to whatever intersection point you want to find first. Okay? There you go, now press enter.
Okay, cool.
Okay, so all your stuff is underneath, stuff is up here, so the intersection, like, for them, I think on 89 it's F5, but on yours it's calc. So
Okay.
green or blue goes with blue, right?
Yeah.
So, yeah, that's where most of your stuff's gonna be for this. Class is gonna be underneath that.
Okay. Well, that's good to know to start off with. Thank you.
You're welcome. That's all? Nothing on here, then, you're good?
No.
Okay.
Close.
Can I have a syllabus?
Oh yeah, I'll go over get one.
Okay.
Yeah. So I need them back.
Our homework?
Huh?
Will you be returning our homework?
Yeah, I'm glad you brought that up because I'm gonna try to stay on top of things, but our semester at our school ends like in about 2 weeks, so I'm getting really crammed with, well, high school kids like to wait a little bit, so to the end because they want to get their grades up so they can still do stuff, I guess. So yeah, I mean I'm getting slammed with stuff, so I'm gonna try to stay up with it and get it to you. So have patience. In about 3 weeks, it'll get much better for me. Okay. I wanted to get those quizzes done, basically, so you can at least see those. What a dummy I am. Okay. All right, so now let's go ahead and take a look at solving these as an inequality. So in other words, our goal is to solve these if they are, what if we have something like this, okay? So how are we going to solve an absolute value that's an inequality? Well, there's actually like 3 different ways to do it, okay? So this time we'll start out symbolically. How about that? And then we'll jump over into the graphic part of it symbolically first. So with x minus 1, absolute value that is less than 4, we're going to do the exact same thing that we did before. We're going to break it up into 2 situations. So we're going to have x minus 1 is less than 4, which is the obvious case. All right, being that it's less than 4, right? But when I think about 1, 2, 3, 4, 1, 2, 3, 4, when I think about a number line, all right, and values, on the positive side, it's simple that we know that if we have 5, that's more than 4. Okay, so 5 would be greater than 4, and we also know that 3 is less than 4 because it's less number of them. But when you are on the negative side, it's not that way, because in this case 5 is smaller, right? And 3 is greater. Okay, so it's different. So when we split this up, we have to take that into consideration. So we're going to go x minus 1, and we're going to compare it to negative 4 because of the fact that the 5 is less than negative 4. We have to switch this sign and make it go that way. So when we're dealing with the negative part, or the negative case, that inequality sign has to switch because of the fact that the value of those numbers, all right, are kind of different, all right, on the positive and negative side. But I'm still going to do the exact same thing, all right. So we're going to go like this. I'm going to try to lasso this thing and get it out of here. There we go. That's kind of neat, isn't it? Then I'm going to do this. So x is less than 5. X is greater than negative 3. Okay? So, let me shrink this down a little bit. What is this? This means that x is greater than negative 3, which means that a negative 2 and a negative 1 will work. So if I put a negative 2 in there, negative 2 minus 1 is negative 3. But what happens to the absolute value of that negative 3? It changes to positive. So see, you went from this side over to this side because of the absolute value. And that is what drives home the fact that we have to change that sign around when you're dealing with that negative case. Yeah?
Is that always with the less than sign?
It is always with any time you're dealing with the negative case. So it doesn't matter whether it's a less than sign or a greater than sign, you're going to switch it. Okay?
Like the negative 1? Is that what you're saying?
No, I'm talking about So this is a straightforward, right? We get that. But when you have to deal with the negative part, remember how we had two parts with the equal ones? So when you have to deal with the negative part, this sign has to switch because of the fact that here, -5 is less than -4, but the absolute value of that is not the situation. Okay. That's why. So we switch that. Now, then this kind of becomes an interesting problem. So x is less than 5, so that's going to be all these numbers. X is greater than -3, that's going to be all these numbers. What kind of a problem does that look like? Yep. And that's what this one is. This is an and problem. So you have to recognize that. All right? That this is actually an and problem. So I put it together like that. Okay? That's how I'm going to put it together. So this is where the and the ors are going to come into place in solving these out.
Is there any other way to tell whether it's like an and or that they just do it in the number line, or do you have to?
Yes, there is. And we're going to find out in a little bit, okay? All right. Okay, so let's try another one. So we're going to go x plus 3, absolute value. Looks like that. Let's make it equal to here, and let's put a 6 there. All right? So again, we're going to do this symbolically. So the one case is the obvious case right here. What's the negative case going to look like? Right. Remember that sign's got to switch around, okay? Because you're dealing with those negative numbers. Once you have it like that, then we're just going to go ahead and do our little solving here. Okay, now I'm going to draw the number line on this. Let's see, less than 3 is going to go that way, greater than -9 is going to go that way. So what kind of problem is this? It's an and problem. Alright, see, I kind of like writing them as inequalities rather than using interval notation. I mean, I don't know what they probably want you to write it as. Oh, they say write it as an inequality. Oh, that's nice. Okay, cool. We don't have to do interval notation on these. Okay, now we're going to answer Vicky's question here in a second. So we're going to go here. This time I'm going to go like this. I'm going to put a 2 there. Okay, so this one was a less than. This one is a greater than. Let's see what happens. So what is our positive case going to look like? Okay, and then our negative is going to be again, we have to switch that sign around because we're dealing with the negative part of that, and the absolute values of those are kind of different. Okay, so then we have this. All right, now again, I'm going to draw the number line on this. So here's 2, here's 6. X is less than 2, so it's going to go that way. Greater than 6 is going to go that way. Which one is this one? This is an or. All right. Oh, what do you see?
When it's the negative, it's the negative and the positive.
You are so close. What's making the difference between an and an or? The symbol. The symbol, right? So which one's an and? If we have an absolute value and I go like this, what's that one? and if I have an absolute value and it's like this, or now it could be like this too, right? So it doesn't matter which. It's going to be either way. Okay? Alright. So there's the difference. So now you know without having to graph it on a number line, you'll be able to tell if it's going to be an and or an or. Okay. Cool. So now we know. Alright, let's do one more symbolically and then I'll show you some graphically. 2x minus 3 equal to 4. Okay, here we go. What's this one? Or. So right away you know it's going to be an or problem. Okay? Because hopefully you've got that written down someplace, so it'll help you remember that. I'd probably put it on the top of the page of this assignment. Alright, then until you maybe figure it out. Okay, break it down. So what do we got for the positive?
2x minus 3 greater than 4, or greater than.
Right, and you know I'm going to put and right now. Okay, here we go. And what's the other one?
2x.
Or this is an or though, isn't it? Shoot. There we go. 2x minus 3 is what? Less than or equal to. It's alright. Negative 4. Okay. And then what do we do now? Yep. Yep. And then we do this little division. 7 halves there. Or negative 1/2 there. Okay. So all these can, you just gotta look at them and decide what they are and then work them out. Okay. Let's try some from a graphical point of view. Not quite as straightforward, but we'll do it anyway. I'll do it on the Desmos here, I think. Alright. Well, just do this. Take that out of there. Alright, here we go. Let's go 5. Okay, so this problem's going to look like, just so you know, the absolute value is x minus 3. Let's go greater than or equal to 5. Alright? Okay, so I want to solve this graphically. So I put the x minus 3 in there, and I put the 5 in there. Alright? And here's what I'm interested in. I'm interested in this point, and I'm interested in that point. Just like I was with before, I want to know what those are. So I negative 2 and 8. So I have negative 2 and 8. Is this an and or an or problem? Okay, good. Alright, so now all I got to do is figure it out what's happening here. So when this absolute value is greater than 5, here's this v right here, here, and then here. So there's like, you see how it's dividing it kind of into 3 sections. You got section here, and section here. So section 1, 2, 3. So, is it greater here or less here than 5? What's happening? Greater, isn't it? This is greater. Okay? So any number that's less than that, which was 2, negative 2, okay? Any number less than negative 2 is going to solve this, because this is when it's greater. Over here, what's happening right here? Less or greater? Greater, so any number greater than 5, or 8, sorry, this is 8, 4. Alright, so that's how you solve it graphically. That's how you would do it. So you have to be able to look at the graph and determine when it is greater and when it is less. Right, so then this one would be, oh, we'll do one. So this is going to be x is less than negative 2 or x is greater than or equal to 8. Alright. Okay. Not very easy to see it graphically, I don't think. So let's look at one. Let's look at it again. Alright. Okay, so here we go. Absolute value. I'll put 2x this time. Minus 1 is less than 6. I'll put that in there. So I'm going to go, and 80, 89 do it the same way. It's not, the graphing, nothing's changed there. Still putting it in the same way. 2x minus 1 and 6, right? Is that what I put? Okay. Again, I'm interested in those intersection points because that kind of sets my boundary here. So there's that one. It says it's negative 2.5. So I'm going to write that down. 2.5. And then I'm going to get this other point, see what it is. Go over here. Now I get down 3.5. Okay. So here's my B. I want to compare it to the 6th line, that's the blue line, right? So I want to know, when is that B less than 6? Well, what's happening right here? B is greater, right, because it's above. Okay, what's happening right here? Less, because the red line is below that blue line there. What's happening right here? Less than what's happening up here. Greater. So that means that it's between these numbers here. Okay, because it's less. So that means we have negative 0.25 to here to here, 3.1. Okay. That's how you would do that. Because this B is less than that 5, that's one inside there.
I just assumed like the one up top would be the
Oh, I don't know. I got wrong. All right. So that's, graphically, it's about the same thing that we kind of looked at Monday. You're looking at that B and checking out to see what happens. So, what if we pop back to here again? I don't think you'll have a problem like this, but it's worth taking a look at. Absolute value of, let's put a negative out front here. Let's go 3x minus 4, absolute value, greater than, equal to 4. Okay, let's do this. So let's say we have something like this, and I don't care which way we solve it. Let's just solve it symbolically, I guess, since I'm on the tablet. What are we going to do first? Divide by negative 2. Okay. Absolute value of 3x minus 4 is less than, because what am I doing? By negative, right? Less than or equal to, what are we going to put here? Negative 2. Okay. So what's the positive case look like? 3x minus 4 less than or equal to negative 2. Okay, that's interesting because that's actually a negative number there. 3x minus 4 is greater than or equal to 2. So is this an and or an or problem? Okay. Alright. Plus 4, plus 4, plus 4, plus 4. So I got a 2 here. I got a 6 here. Oh, that one worked out. Write everything by 3. X 2/3. X greater than or equal to 2. Did I do everything right? We're good? And this is an and problem? So let's see. 2/3 is the smallest number. X is less than 2/3. Wait a second here. What? Let's graph this. So 2/3 is here, and 2 is here. And if I graph this, X is less than 2/3, where does that go? So that's going to go this way, right? And if I graph this one, where does it go? I thought you said this is an and problem. Did you say this is an and problem? Where do they intersect? But we switch it to and when we divide it, right? So it's an and problem. But where do they intersect? They don't intersect, do they? Right? They don't intersect. You know why? Is the absolute value ever going to be less than a negative? Doesn't have an answer, does it? No, it doesn't have an answer. Absolute value is always positive. Yeah, somebody could have told me right here and said, absolute value is always positive. But nobody did. Okay? So I don't know if you'll see one like that, but if you do, see if I showed it to you. All right. So you could get some, kind of crazy situations where, you're not going to get a solution. Okay. I don't know if you will, but it's out there. All right. And the reason why it triggered me is because X can't be less than 2/3 and be greater than 2. It can't be that way. That number, you can't have a number less than 2/3 and greater than 2. It isn't going to work. All right, that doesn't work. Let's see if there's anything here that I don't think that you guys I just don't see anything you're not going to be able to do. Solve an inequality, interval notation, absolute values, equal to 0. Any questions on anything? Okay, so I will try and get something. You want one of those guys things, don't you? Okay. I'll try to get one up. Can everybody access that desire to learn thing okay? No? Yes. Okay. So I'll try to put it on content and files. I'll put it up on that. I'll try to get it up there about Friday or Saturday or so. Okay? And don't forget to hand your quizzes back to me before you take off tonight. And if you have any questions on anything, make sure you ask. I'm going to hand out this quiz to you. Let me stop this for the